Hi, and welcome back to my series on overhauling and modifying the Chinese 7x12 lathe. Thanks for all the excellent comments for the last video. One comment especially really stood out, and that was from CG Precision, who recommended a different method to check the perpendicularity of the cross-slide ways. What he suggested was put a pair of end mills into the V-way and then clamp a engineer square against them. So then with a dial test indicator attached to the base, you can measure the perpendicularity directly without any of the errors of the headstock coming into play. So it seems like a good method. What I'm finding is a huge error. Turning the square around in the other direction shows what the problem is. What's the name for a square that's not a square? Now the next square in my collection is this one. I bought this from a surplus machine place in Slovakia. It's only ground. Oh no, this one's also been a little scraped on the inside, although it's had a few dings and it's seen a bit of life. It's marked MU07 with a Skoda logo on it. Well, this square definitely makes a better impression than the last one. For this to cut concave, it should have a very slight rise as you move to this end. Which it does. Not much, but there's a very slight rise. Thanks very much to CG Precision for pointing out this method. Excellent. Thanks a lot. Keep those good comments coming, guys. I got asked about that saddle lock from the last video. These are the parts of it here. Basically, it's made out of a block of steel, 39 by 20 by 26 millimeters. There's a slot cut out of it, which is 7 by 15 deep. Sorry, it has 7 mil sides, it's 12 across, 15 deep. Pair of 5mm holes with counterbores drilled on the side. That's where it mounts onto the saddle. And a pivot hole, which is also a 5mm hole, which goes almost all the way through, but not entirely. So this is the pivot, just goes in here. It's held with a pin. I must go the other way, sorry. Goes like that. And this is just an M6 threaded little handle I made. That screws in and basically presses down on one end, which tilts up the other side like a seesaw and clamps the bed. Nothing to it really. I don't think any of the dimensions are very critical. Just make it to fit your machine. Remember last week I'd finished off scraping the cross slide and saddle to the bed and to get it to alignment. So this week I need to make up a new gib strip because this one's too short. I made a new built-up cross-slide, and I made the cross-slide longer to give me a bit more travel, but I never bothered to make up a new gib strip back then, so now it's time to make one. So to do that, I'm going to need a piece of cast iron, quite thin, high-quality cast iron, long, skinny. Now in the 21st century, in a big city, where do you go about buying a piece of well-seasoned, reasonably thin, high-grade cast iron? Easy. Disc brakes. What I'm going to do, lop a piece off this old brake rotor through here and then make my gib strip out of this piece. Cast iron's got many fabulous characteristics for engineering. One of them being that it's very brittle. When you look at the fracture surface, you can see what lovely fine-grained cast iron brake discs really are made of. Lovely material. So I think this should easily be thick enough to get the gib strip out of. Here are the dimensions of the new gib I need to make. So it's just about 1/4 of an inch in the one direction and 5.5 millimeters in the other. I'm not quite sure what the angle is. I'm not going to bother measuring it. All I'll do is set up the angle plate using a dial test indicator to give me that angle, and then make the new one to the same angle. Here's the original gib. It was about 5 millimeters by 5 millimeters. So we should be able to make the new one much closer to the actual size of the hole. Hopefully close to Connolly's close fitting gib. Before we start worrying about the angles, the first thing I need to do is thin down the brake disc in this area to the 6.2 millimeters. I may as well give it a first scrape, sort of just to roughen up the surface and get it nice and even while it's still easy to hold, because once it's cut down to the size of a gib, it's going to be a real pain in the neck to hold the thing. Dialing in the angle plate to the angle of the dovetail way through here. So the dial test indicator is moving. That means that we're not vertical yet. Just slowly reducing the angle a bit at a time until we get there. That's now dialed in nicely, and I've tried it in a couple of different places. And the angles showing on the rough scale 30 degrees, so 60-degree dovetail. Here I'm tramming in the angle plate. Just be mounting it under the strap clamp with the stock hanging over this edge for cutting. Those were not the most efficient toolpaths which I used, but I knew I was going to end up with this long, quite skinny piece of cast iron supported only at the ends. So I wanted to use nice light cutting passes so that it didn't break or get damaged in any way. At the moment, the gib's still slightly oversized. It's a couple of tenth of a millimeter oversized in the thickness in this direction and only a couple of hundred in this direction. So what I'll do is I'll just give this a scraped finish to pick up oil. I'll touch it off once I've taken it off the frame. I machined it in this way to keep it on the backing frame as long as possible, because it's going to be very difficult to hold this once it's just a weirdly shaped single piece. I think I've now got it as accurate as I can possibly make it without offering it up. So next step will be to cut it off and try it out. So here's the gib. It's still a little bit too long, and it's still a little bit doesn't go on either that side or this side yet. So I'll glue it up, touch it off, and see where I need to remove metal, and let's get this fitted. So that's only touching on the ends. I knew the ends were a slightly bit thicker than the rest of the body of the gib, so I need to take those down a little. And then the other direction, it's the same. This is the side which is going to have the screws against it. There's really no point scraping that. They've got a couple of little tiny machining marks, but they're barely tactile. So after what seems like approximately 1 million scraping passes, it's starting to look quite good. It's also nearly going in the full way. Just tightens up at the end. So the whole system's got a slight deformation in it, but for the most part it's getting very close. I've finished fitting up the new gib strip. There's a comparison to the old one. So you can see it's both longer and significantly wider in the bearing surface. And it fits very, very tightly. I guess the close-fitting gib, as Connolly calls it. Here you can see the new gib strip fitted. I made sure that it's flush at both ends of the cross slide, so it's the full length supported. So next up, I need to drill some more holes to support the gib strip more evenly. This center punch is something I made at school when in metalworking. I guess I must have been maybe 11 years old when I made it. Hardened end, which comes loose, but otherwise it works quite nicely. It's a nice tool. This little machine vise was an apprenticeship project made when I was in the Air Force. They basically just gave us blocks of steel, and the only power tool we really used for the most part was we're allowed to use a drill. Otherwise it was all hand sawing, hand filing. Yeah. At the time we thought it was pretty darn torturous to have to file all these chunks of metal to within 1/1000 of an inch. But in hindsight, it certainly gave a good feeling for tolerances. My wife says I should hit up Iki Nohut Haslama for some sponsorship for my videos. Next I'll just deburr that inside edge. Next I need to drill down into the gib to give a nice divot for the adjusting screw to push against nice and straight. I'll set the depth stop on the drill to make them all consistent depth. The original Sieg supplied adjustment screws for the gibs have this little portion here without any threads on it, which presses into the gib strip. So that's what I need to do on these additional set screws that I'm going to use. So I need to set up the lathe to turn those. I hope you all have a bed protecting board for when you change chucks. This is just a thread protector. That's probably not the last word in gib adjustment. They're probably a little bit too tight. That's kind of a stick slip sort of feel, but there's absolutely no movement in that cross slide whatsoever. It feels really nice. So I guess we'll call that another completed task, shall we? Finishing that cross slide seems like a good place to finish this video. If you're enjoying these videos, I'd appreciate if you send a link to someone else. Otherwise, thanks a lot and see you till next time.